Hello everyone, good afternoon. I hope I'm audible. Dear authors and invited guests, welcome to the technical session 9F. My name is Siddhi Auti and this session would be moderated by me. On the behalf of Global Knowledge Research Foundation and GR Scholastics LLP, it is my great pleasure to welcome you all to the ninth International Conference on Information and Communication Technology for Intelligent Systems, ICTIS 2025, Bangkok, Thailand. The ninth edition of this international conference is being organized in a hybrid mode. The physical event was held the day before yesterday, and the virtual event is being held via Zoom meeting today and yesterday. That is 5th and 6th April. I hope you all will enjoy this interactive session throughout the day. In this session, in total, we will be having 10 presentations. Each presenter will be given a time span of 8 minutes for the presentation and 2 minutes for question and answers. After 8 minutes, I will be raising a gentle reminder to conclude your presentation. I hope everybody understands the time constraint. Also, there is another request all the participants that you stay connected with us till the closing remarks. And if you face any query or issue, you can write it to me in the chat box. Now, just before we get started, I would like to introduce you all to today's session chairs. The first session chair is Professor Vishnu Kumar. Professor Vishnu Kumar is an assistant professor in the Department of Industrial and System Engineering at Morgan State University, Baltimore, Maryland, USA. His research focuses on the applications of data analytics and machine learning in manufacturing, supply chain, and healthcare. With publication in esteemed journals and conferences such as ASME, JSISE, Mental Health Research, and ASME, IMECE, he is dedicated to advancing AI-driven solutions in smart manufacturing, public health analytics, supply chain resilience, and engineering education. Welcome, sir, to today's session. And the another session chair we have here today is Dr. Amit Thakur. Dr. Amit Thakur is working as a professor and head in the Department of Computer Science and Engineering in the Faculty of Engineering and Technology, Charusat University, Gujarat, India. He has published three books in the areas of data mining. He has also served as a member of the technical committee at various national and international journals, conferences. His current research interests machine learning, deep learning, and embedded deep learning. We also welcome Dr. Amit Thakur for chairing today's session. Now, without any further ado, we'll go on to the first participant. First presenter is Sahil Ambokar from Pimpri Chinchwad College of Engineering, India. And the paper title is A Comparative Analysis of Blockchain Technologies for Secure Electronic Voting Systems. I request Sahil to please start with your presentation.
Hello, good morning, everyone. We are pleased to present our paper titled The Comparative Analysis of Blockchain Technologies for Secure Electronic Voting Systems. I am Sahil Ambugar and I am joined by my teammates Atul Pawar, Sanket Ahirao, and Vedant Gauthier. Our problem statement is electronic voting systems are becoming more popular, but they face serious challenges related to security, transparency, and voter trust. Blockchain is promising technology, but not all blockchain platforms are suitable for secure voting. So our research aims to analyze and compare various blockchain technologies to identify which are best suited for secure and reliable e-voting systems. Next is motivation. So the motivation behind our research paper title is Secure and Transparent Elections are Essential for Democracy. Blockchain, with its decentralized and tamper-proof nature, offers a strong solution. Our motivation is to explore which blockchain platforms can effectively support secure e-voting and in doing so, help improve trust and efficiency in elections. Objective and scope. The main objective of our research is to compare and evaluate different blockchain platforms
Excuse me,
to
sorry
find
for
the
disturbance, but I cannot see your slides. I can only see the
uh,
title slide.
must slide is not available. Is it visible now?
Yes.
Sorry for the So the objective and scope. The main objective of our research paper is to compare and evaluate different blockchain platforms to find the most suitable one for implementing secure, transparent, and efficient electronic voting system. Our scope includes analyzing key platforms based on factors like security, scalability, consensus mechanisms, and practical applicability. Next is literature survey. We conducted an extensive literature review. Starting in 2015, Swine introduced blockchain for digital governance. This kind laid the foundation for privacy in blockchain systems. In 2017, ICE showed how smart contracts could protect data integrity. In 2018, Beck developed a secure developed and secure voting protocol using Ethereum. Other notable works include Hazel Marshall's evolution of consensus mechanism and Hardwick's exploration of fraud prevention. Koch introduced a hybrid blockchain model. Akbari emphasized usability and trust. More recently, Yavuz proposed layer 2 solutions to improve scalability and speed in blockchain voting systems. Common findings and gap findings. From the literature, we observed that blockchain provides security and transparency, but scalability remains a major challenge. Voter privacy and smart contracts integration are essential. However, we found gaps like limited real-world implementation, resolved high transaction costs, lack of user-friendly, and minimal attention to legal challenges. So our proposed system architecture is presented through the image. So first, the voter will register himself through our web application, and first we will validate the voters through the smart contract. Our proposed architecture leverages blockchain score features. It includes the secure front-end for users to cast votes, a blockchain backend for immutability, and smart contracts to automate validation and counting. This design enhances both transparency and efficiency. So in our proposed system architecture, first the voter will be validated through the smart contract and will be allowed to vote. Once the vote is registered, it will be noted to the transaction in a blockchain, so it cannot be changed, and that block will be transferred to the database for evaluation of it. Next is algorithm search. We compared several consensus algorithms like proof of work, though secure is energy intensive. Proof of stake is more efficient and scalable. Delegated proof of stake allows faster validation through elected validators. Practical Byzantine fault tolerance is energy efficient and based for private or consortium blockchains. So PBFT is an algorithm which ensures that even if there is a fault in some node, the whole system will not crash and will continue to run. So, applications of our blockchain-based voting system. Blockchain-based voting can be applied in various scenarios, such as national and local elections, campus elections, political party decision-making, public opinion polls, and corporate board voting. Its flexibility and security make it suitable for all levels of electoral systems. Advantages. There are numerous advantages to using blockchain in e-voting. Enhanced security against tampering, full transparency, voter anonymity, decentralization, easy auditing, remote accessibility, and significant cost saving due to reduced physical infrastructure use. So, in conclusion, blockchain has the potential to transform electronic voting, while platform using POS and BPFP offer the best combination of security and efficiency. Challenges of Challenges like scalability and regularity hurdles still exist. Continued research and testing are essential to fully realize blockchain's potential in this field. We have referenced a wide range of studies to support our analysis, from foundational papers on blockchain voting to recent implementation evidence. These resources provide essential insights to our evolution, challenges, and future of blockchain in evolution. Thank you for your time. and attention. We will be happy to take any questions you may have.
Thank you, sir, for your presentation. Is there any question from session chair?
I have a quick do you have any results, experimental results to show?
Hello.
Do you have any experimental results?
Sir, we have not implemented any results, so we have not implemented any application yet, but we are currently developing a web application for this semester.
Okay. In future, if I want to compare your proposed work with the existing work, what could be the possible measures we may use for comparison?
Sir, so our primary focus will be not on conducting a national level elections. It will be basically on conducting small level elections like in colleges or in political parties itself. So currently the work done is based on national level elections. So our the difference will be that our project will be on small level. So it will be much faster than the currently work existing.
Okay, thank you.
Thank you, sir. Now, if there are no questions, then I can proceed to the next presenter. So the next paper title is a survey of LORA and LORA WAN technology in transforming IoT applications. And this paper title will be presented by Muhammad Asif from Parul University, India. I request Muhammad Asif to please start with your presentation. Hello.
Hello, is my screen is visible?
Yes.
Okay. First of all, thanks for giving me an opportunity to present my topic, Survey of LoRa and LoRaWAN Technology in Transforming IoT Application. I am a PhD scholar in Parul University in Computer Science and Engineering Department under the guidance of Sanjay Agal sir. Where day-to-day life is increased or uses the internet, simultaneously increase the automation. Automation will be increased, and that will be handled by the IoT required a cloud-based computing, and cloud-based computing have some limitation that have power consumption. Power consumption means cloud-based computing require more and more power consumption. Due to that, many automation is not possible. So to make them possible, the LoRa and LoRaWAN technology will be introduced for reliable communication and operated on battery operated devices. This article mainly analyzed the different types of LoRa devices that have different frequencies and that have different power consumption capability to transmit the data from one place to another place securely. First of all, I want to ex- First of all, I want to explain the LoRa. There is two things, LoRa and LoRaWAN. In IoT, to make the automation possible, the huge amount of power is required, which is commonly obtained by the Wi-Fi and Bluetooth devices. But if we require to transmit a data from one place to another place with a low power and wide range of area to travel data from one place to another place, then it is not possible in the cloud-based architecture. That is possible with the help of the LoRa and LoRaWAN technology. Actually, LoRa and LoRaWAN technology is licensed by the Symantec 2014. It is a frequently changing generate frequency over the time. It has two chip type, that is base and tweak chip. This base and tweak chip functionality is frequently changing the frequency over the time. And when frequency is frequently changed over the time, the spreading factor is required. If spreading factor is less, then power consumption is less. And if spreading factor is greater, then it will takes more and more power. That will also capable to handled by the battery operated devices. In LoRa, there are different three types of devices, A, B, and C, that have the different capability of manipulating the frequency and capability of consumption of the power. In type A device, having the spreading factor SF12, that means it will SF7, that will it will take low power. Often in sleep mode, it can transmit the data, whereas in type B device, it will consume more power as compared to type A, and that will another one is type C device that will consume more and more power as compared to A and B. Problem statement is this: in LoRa and LoRaWAN technology, popular wireless communication technology used for low power, long range IoT application. In low power and wide long range power communication required, if required, we must ensure the security vulnerability. Means at the time of data transmission, there is no hampering of the security. Because I am a post-quantum cryptography researcher, and according to post-quantum cryptography researching, RSA algorithm is provide an AES and ecliptic curve will be providing the security for communication, and that will be break by the Shor algorithm. And if you, by using the Shor algorithm, if we having the key for private public pro encryption and decryption, then we can break every and every security. So when the time will be uh, go moreover forwarded, the security will not be hampered. And if we want to transmit a data from one place to another place with efficient energy, means optimize power consumption. The application of LoRaWAN protocol is mainly including the health monitoring, agriculture, and many more sector. I will just conclude few of them, just like wireless gas monitoring system. In wireless gas monitoring system, gas container working as an intelligent jar. This jar will have some fuel level, and when fuel level is dropped down, it will send the message through the LoRa based gateway to the IoT cloud, and through the IoT cloud, it will transmit it to the expected sender alert. Okay. The next application is radiation leakage detection. Where the companies will be established, just like GITC in Gujarat, there are some population living into the particular area, and if radiation leakage is happen into the GITC on industrial area, that may hamper the human life. If we protect the human life with the help of the IoT, then we must know about the alert system, and that alert system will be alert by the LoRa and LoRaWAN technology. This will be notified to the facility manager through their computer or phone to manage the radiation leakage or to away the population from their particular industrial area. Simultaneously, LoRa and LoRaWAN medical refrigeration application is also available. In medical refrigeration, there is a need of the many medicine which will maintain the temperature.
Hello.
Yes.
Sir, sorry for the interruption, but we are past the presentation time.
Okay.
Uh,
Okay.
can we please conclude it?
Okay, conclude. Okay. Similarly, medical refrigeration is also application simultaneously location stolen vehicle cargo. If a cargo will be stolen, then we can easily find out that with the LoRa and LoRaWAN technology, predicting maintenance. If some robotics devices required the maintenance, then it will automatically it will also be alerted by the LoRa and LoRaWAN technology. The conclusion of this is we can using the LoRa and LoRaWAN technology, we can efficiently transfer the data from one place to another place with low power consumption and frequency ranges using the IoT. We uses the many more references, but I conclude them in 10 here. Thank you. Hello.
Thank you, sir, for your presentation. Are there any questions?
How your idea brings novelty to the existing solutions?
Sorry, sir.
How is your idea bring novelty to the existing solutions? What is the novelty in your idea compared to existing solutions?
No, sir. Okay. Currently, why I am studying about this? Currently, I am a post-quantum cryptography researcher, and in post-quantum cryptography researcher, in the future, the battery operated devices also having the security vulnerability. So to by using the side channel attack of post quantum cryptography, we must need to know about the power consumption of a processor, diode, and other hardware devices like FPGA. Means which devices having how much power consumption. That's by using this information, hacker can easily manipulate the data and generate the private and public key. So to protect that system, we need to find out the power consumption by the different devices, and we regularly manipulate that power consumption throughout the encryption and decryption process. That why attacker cannot capture that data and encrypt or decrypt the authentic data. That's why I am study about the power consumption features of LoRa and LoRaWAN technology.
Okay, thank you.
I had a question. So, if we are in a location which has limited infrastructure, then how can you use this technology? How can you scale this technology in those situations? Is there some possibility?
Limitations is
So, if they have less infrastructure, like if you are in a remote village,
everywhere a network will be available. Every provider having, every village having the network operator, and in that network operator we just mounted a LoRa based gateway on that network. By using LoRa based gateway on that network, we can easily communicate that data from the devices.
okay.
In this scenario, LoRa based gateway is very important.
Okay. Okay. Thanks.
Thank you, sir. Now I'll go on to the next presenter. So the next presenter is Prachi Patel from Charotar University of Science and Technology. And the paper is automated liver cirrhosis prediction using ML, machine learning. Ma'am, could you please start with your presentation?
Yes, ma'am. Good afternoon, everyone. We are excited to be here at ICTIS Thailand 2025 to present our research on machine learning based early detection of liver cirrhosis. I am Prisha Patel, and with me is Prachi Patel. We are from Charosat University, India. So, liver cirrhosis is a serious global health issue, and its early detection is critical. Our project aims to explore how machine learning can help doctors predict liver cirrhosis early, quickly, and accurately. So, let us begin by understanding what this problem is. So, what is liver cirrhosis? Liver cirrhosis is a disease where healthy liver tissue is replaced with a scar tissue, making it harder for the liver to function properly. The biggest challenge is that it has no symptoms in the early stages. So by the time it's diagnosed, it is usually too late. Current detection methods include biopsies, CT scans, and the blood test, which are often expensive and slow. So this is where AI and machine learning comes in. They can analyze large amounts of patient data and predict cirrhosis early without invasive tests. Now, Prachi will introduce the technology stack that we have used.
Thank you, Prisha. Well, talking about the technology stack, to build an efficient ML model, we experimented with 4 different algorithms. The first one is linear regression, that is basic but not accurate for complex medical cases. Then we proceeded towards logistic regression, which works well for classification but has limitations. Then comes a decision tree, which captures complex patterns, but it has some overfitting problems. And to overcome that, we move towards random forest. That is our best model with 97% of accuracy. These models were tested using real-time medical datasets to see which one works best. Well, now let us have a look at the literature review. We have reviewed 5 papers, and from that, the best technologies and techniques that we have found are random forest classification with 97% accuracy. From the second one is KNN, K nearest neighbors, with 62% accuracy. The third one is AdaBoost, which proposed voting classifier achieving 94.48% of accuracy. The fourth one is logistic regression. And from that, the conclusion is accuracy, precision, recall, and defense score. And the last one is random forest, which solved with 73.05% of accuracy. Now I would like to hand it over to Prisha.
Okay, so now let us look at a comparison between the traditional method and our machine learning approach. For this comparison, we have included 4 main features. The first feature is accuracy. The old methods rely on doctors' experience. In contrast, machine learning improves as it gets more data. The second feature is pain. The traditional methods may need biopsies or CT scans to confirm whether the patient is having liver cirrhosis or not, wherein our system uses the simple blood test data. The third feature is cost. Many medical procedures like biopsies can be expensive. So the machine learning method uses blood test data, which makes it cost effective. The fourth feature is speed. Old methods take time to confirm, wherein the ML approach gives the result much faster. Now, talking about data sets, for this study, we have used 3 publicly available medical data sets. These include liver cirrhosis prediction dataset, Indian liver patient dataset, and predict liver disease dataset. That is a dataset consisting of 700 records. 1700 records. Sorry. These data sets include important medical features like age, gender, liver enzyme levels, bilirubin, albumin, and alcohol consumption history. So, to ensure high accuracy, we have cleaned the data, removed the missing values, and standardized the features before training our models. So, now Prachi will explain how we have built our model.
Well, talking about the methodology, we followed a 5-structured process to develop our model. The first one is data collection, where we gathered data sets with over 1700 patient records. Our second step is data pre-processing, where we cleaned and normalized the data to handle the null values. Then our third approach is model training, where we trained and tested 4 different ML models. Our fourth step is model evaluation, where we measured accuracy, precision, and recall. And the fifth step is practical implementation, where we analyzed how this model could help doctors. Well, talking about the implementation and experimentation, we tested our model with 3 different data sets. The first one is cirrhosis prediction dataset, which achieved 97.2% accuracy. The second one is Indian liver patient dataset, which also maintained 96.8% accuracy. And the third one is predict liver disease data set having 1700 records, which also ensured consistent performance with accuracy of 96.9%. We have a visual comparison of the accuracy levels of 4 different machine learning models that we have used in our analysis. Linear regression achieved accuracy of 59%. Logistic regression improves the performance with accuracy of 89%. The decision tree further boosts the accuracy to 91%, and random forest outperforms all other models with impressive 97% of accuracy. This is the detailed methods comparison table with precision recall and FN score. Here is the timeline chart of our project, where we started in early December by setting our objective and literature review, then moved towards data pre-processing until the half of December, and from the last week of December to first week of Jan, we developed the baseline models and done tuning and validation to improve our accuracy. In the last week of Jan, we started writing our draft, and by early Feb, we focused on refining results like graphs and comparisons. And in the half of Feb was spent on proofreading and finalizing the conclusions. And finally, we
Hello.
made our final submission by 4th of March. I would hand it over to
Hello.
Isha. Yes, ma'am.
Ma'am, sorry for the interruption. But we are past the presentation time. Can you please get to the conclusion?
Yes, ma'am.
So, in order to summarize, here we have used machine learning approach to predict the liver cirrhosis. Even though it has some limitations like data imbalance, black box problem, that is ML model is complex, making it hard for the doctors to understand. The computational power, that is random forest, requires high processing power, but which may be an issue like for real-time applications. And in order to improve this, the future scope is we can make it more explainable for the medical professionals by integrating it with the websites. So here we summarize that this research can help in early detection, reducing invasive tests, and supporting doctors. Here are the references that we have used for our study. These are from the journals like IEEE Explore and AI-enabled medical diagnosis. Thank you for your time. We are happy to take your questions.
Thank you, ma'am. Are there any questions?
Is it a problem of classification or regression?
Sir, basically, we started with the yes or no decision with linear and logistic regression, but as a part that we have multiple columns to be on the basis of that we would be having our decision. So for that we use random forest, that is a combination of both the processes.
But have you achieved accuracy in linear regression?
We have used features like age, gender, albumin,
What is your target feature?
Target feature is min samples and max samples. On the basis of that, the clusters are formed, and on the tree classification, our answer comes.
Okay, and which method you have used in random forest to combine the results of multiple trees?
ADA boost.
Okay, thank you.
Thank you, sir.
So
Thank you,
one
ma'am.
question I had is, yeah, so you mentioned about the class imbalance. So how did you manage that?
Sir, what the data has, it has less number of cirrhosis detections, but more number of fair cases where there is no detection. So that is a bias, and for that we have used multiple data sets, and combining those multiple data sets, we have achieved our final result.
So were the other data set balanced, or did they have also class imbalance?
No, they have balanced.
Okay, and all of these data set had the same set of features like age,
Yes,
Mm.
we have considered the same set of features.
Okay. Okay.
Thank you, sir.
Thank you, ma'am. Now I'll go on to the next one. So the next presenter is Divanshu Suri from Banastali Vidyapit, India. And the paper title is Development of an Admission Chatbot for a University Using LLM. Divanshi, ma'am, can you please start with your presentation?
So, good afternoon, everyone. My name is Devanshi, and today I will be presenting my paper titled Development of an Innovation Chatbot for University using Large Language Models. This is the presentation, this is the structure of the presentation. The emergence of AI-powered chatbots has significantly transformed the nature of human-computer interactions, particularly in the domain of information retrieval. Large language models such as GPT-4 and BERT play a
Hello?
crucial role in
Uh,
enhancing.
Ma'am, sorry for the
Yeah.
interruption, but your voice is very low. Can you please do something
Okay.
about it?
Okay.
We are not able to hear you properly.
Um, am I audible now?
Yes.
Okay. The emergence of AI-powered chatbots. Okay. The emergence of AI-powered chatbots has significantly transformed the nature of human interactions, particularly in the domain of.
Ma'am, you're not audible actually. Your voice is gone again.
Okay.
It's very low.
Can
Ma'am, if you're wearing headphones or anything, consider removing it once.
no, anything. Can figure out the microphones. Can uh, hello. Am I audible?
Ma'am, your voice is very low actually. It's almost we cannot understand what you're trying to say. Ma'am, if there is some technical issue, right, we can have your presentation in a while. We can have other presenters right now when you're in a stable internet. Is that all right? Yes, sure. Thank you, ma'am. Thank you for cooperating. Can you please stop sharing your screen? Okay, thank you. Okay, so the next presenter is Meet Wasawa from Charotar University of Science and Technology, India. And the paper title is Enhancing Road Safety, LIDAR and Machine Learning for Pothole Detection. I request sir to please start with. Okay, I will go on to the next presenter. So the next presenter is Supriyo Saha Himu from American International University, Bangladesh. Sir, you're there in the meeting. Please give me a response.
Yes,
Please start with your presentation.
sure.
Thank you.
Good afternoon, everyone. Myself, Supriyo Shahimu. I am a postgraduate student from American International University, Bangladesh. So today my topic is about hybrid Archimedes Osprey algorithm to enhance economic load dispatch in renewable integrated smart grids. So here is the table of contents list that I will cover in my presentation. Come to the next slide. So first of all, we have to know actually what is ELD. So ELD means economic load dispatch. In simple words, it is a process of determining the most economical way to share the load among the different generate units in a power system and control their outputs to meet the load demand at minimum fuel cost. By using ELD, we can actually decrease the energy production expenses and can also combine the renewable energy sources with a grid dependability and also and operation stability. Here is the literature review. The slide actually reflects the sources from where we gained the ideas to work with this topic. There are only 8 topics. Others are on the reference slide. So it's actually the research scopes. Based on the literature review, we find some research scopes and different optimization techniques for ELD. We have already integrated the renewable energy in our microgrids, and it's a smart grid application which have a multi-objective optimization. We can also use in it real world implementation, and we have some future works with the algorithm enhancements also. So here is the goals of research. Based on the literature review and research scopes, we have improved sub-noble ELD research goals by using hybrid optimization. We can reduce overall generation costs, can maintain stable power output across the interconnected microgrids, and can increase the utilization of different renewable sources like wind, hydropower, and so on. And finally, we can also reduce energy losses and achieve a higher energy output for a better power system. This is actually the proposed system architecture. Here is the control center. In the first image, we can see that there are 3 demand sector: industry, house, and community, and there are 5 generation unit, which is hydropower, solar power, power station, wind power, and also generator. The generation capacities, cost, data emission rates are given in the table. We actually took this data for the optimization, and in the below the load demand distribution base curve is showing. This graph contains actually IEEE 118 bus load demand curve for 24 hours. Based on the load demand, I considered ELD process to mitigate the demand of my generation. This is actually the system constraints what we took to complete our optimization. We have took the power balance, generation limits, and storage operation constants. We have also some objective function which contains O&M cost, the generation costs, and other costs to mitigate the generation. This slide actually represents the methodology. This flowchart represents the ELD process of the proposed model. It begins with 4 key points: water flow forecasting, hydropower plants, and real-time data forecasting, also the sunlight forecasting. It also includes wind forecasting. Next, the process is initialize the sample and set the iteration number, starting from sample 1. Different power stations are then initialized based on the constant inputs given in the previous table. After that, model evaluates and updates the best power fitness before proceeding to the objective function, which includes emission level, operation and maintenance costs, and generation unit costs. The hybrid Archimedes-Osprey algorithm is then applied to optimize the objective function, and then the system check the fitness and updates the microgrid power. If the best output is achieved, the data will recorded and the process will be end. And if not, the iteration restart from the sample 1 until a optimum solution is found. Come to the next slide. Here is the hybrid Archimedes optimization, Osprey optimization. Actually, we have interconnected 2 optimization like hybrid, like Archimedes and Osprey, and we made it as a hybrid form, and we get a better outcome from the conventional method. So after simulating the process, we have some result. We can see that if we don't optimize the system, the power generation And the power station generates actually 1.29 megawatt, but allows only 4 megawatt total. And the wind generates 0.86486 megawatt and serves already 21.6 megawatt, which includes the industry and community. And it also indicates the significant supply demand mismatch. If we come to the cost efficiency, then we can say that the hydropower has the lowest cost at 52.9730, followed by the solar is higher. It is to $64.8649, and the wind has the highest cost, that is 715.1351 due to the intermittency and maintenance. And finally, we can say that the renewable solar and hydro are cheaper and have lower emissions versus power station. Come to the next slide. This slide contains actually the hybrid and Archimedes Osprey optimization. So if we use hybrid optimization, we can improve the distribution and also the efficiency. The HOA method balance the power generation, especially from renewables, and boosting also the system performance. We can get lower
Hello.
cost and emission.
Sir,
Hello.
sorry for the interruption, but we are past the presentation time. Can we please get to the conclusion?
Sure. So there will be a stable and also sustainable output. The generation ranges from 1.95 to 9.73 megawatt with stabilized 158 to 9.92 to 794.59 hour, supporting peak demand efficiently. So it's actually reduce the emission, stabilize cost power, and it's also the allocate balanced. So finally, we can say that we can achieve 65% reduction in the unstable grid periods, 66.6% reduction in power mismatch, 80% reduction in the emergency controls, and 60% reduction in frequency deviation, and also enhancing grid frequency regulation. Finally, 60% faster response times to fluctuation and reducing the risk of cascading failures. So here is my future scopes. There are advanced methodologies and interdisciplinary approaches and also real-time implementation. And this is the reference from where we can get the ideas to work with this project. Thank you, sir. Thank you all. If you have any question, please continue.
Have you used a single objective function or multi-objective function?
We have actually used multi-objective function. But firstly, I have used one objective function that is described in the system constraints.
What is the rationale for doing this hybridization and how it affects the efficiency of algorithm? Will it take more resources to now run?
Sir, please, can you repeat the question?
What is your rationale for doing hybridization in the approach? Will that lead to more resources for the system?
Sir, I can understand your question, sir.
Why you used or why you combine these two optimization techniques?
Oh, okay. Sir, actually, if we use one like Osprey or Archimedes, there are less advantages. So we try to combine this. And if we see that if we combine this and make a hybrid system, then it has a great advantage rather than the conventional one, like only Archimedes or only Osprey. So that's why we hybridize both Osprey and Archimedes twice.
Okay, thank you.
Thank you, sir.
So you said
Thank
in
you.
your work you are using multiple sources, right? Like sun, wind, water, etc. So
Yes.
let's say if let's say in the night you won't get any solar energy, or let's say if the wind is not there and there are some fluctuations. So then how
Yes.
do you ensure that the demand is maintained? So use your model able to maintain that, ensure that the demand is still maintained.
I got it, sir. Sir, it's actually a microgrid. So when there is night, there is no solar power, or so we can allocate the actual power from the power station, and we can also accumulate the power from hydropower. But if there is dry season, there will no hydropower, but there will be sun power. So we can allocate the power from the solar power. This way we can use actually this model. So if one part is missing, but other three parts are open to allocate the power. Actually, this is the meaning of my meaning of my comments.
Okay. Okay. So at least there should be 2 or 3 of the other
Yes,
sources
yes,
available.
sir.
Okay.
If there is no renewable resources, we have power station and we have generator, so we have a backup to ensure the power stability by generator and the power station. I think you will understand my
Okay.
comments.
Yeah. Okay.
Thank you, sir. Now I'll proceed to the next presenter.
Thank you.
Devanshi ma'am, will you be able to present now? Are you in a stable internet connection? Ma'am, if you can present right now, please give me a response. I think we will have to continue. So the next presenter is Vineet Jogesh Bhole from Manipal University, Jaipur. And the paper title is IoT-based robotic arm control. Sir, you are there in the meeting. He's also not there in the meeting. We'll continue. Next author is Sneha Vasist from Ajay Kumar Garg Engineering College, India. Ma'am, you are there in the meeting. Can you start with your presentation?
Yes, yes,
Okay.
sure. I would like to call Sneha Gupta, my co-author, to share the screen for the presentation.
Yes, ma'am, no issues.
Okay, kindly do it in slideshow mode. Okay, thank you. So, good morning, everyone, here at ICTIS Bangkok. My name is Sneha Vasist, and I'm truly honored to present my research titled as Polycystic Ovary Syndrome: Challenges, Advancement, and Future Directions in Women's Health. Our problem statement is to identify accurately what are the major factors that can contribute in identifying the polycystic ovary syndrome, as it is a multifaceted disease. Polycystic ovary syndrome, commonly known as PCOS, is a complex endocrine disorder that affects approximately 1 in 10 women of reproductive age worldwide. In earlier times, it was only restricted to as a reproductive disorder, but after several researches, which is going on right now also, it has been concluded that it has several other factors also involving to finding out the possibility of polycystic ovary syndrome. Despite being one of the most common hormonal disorder, PCOS remains underdiagnosed, underrated, and widely misunderstood. It's not just a reproductive disorder, but also affects metabolic health, mental well-being, and even long-term cardiovascular disease. My research focused on identifying the key challenges women faces with PCOS, the recent advancement, and its diagnosis and treatment, and the future direction need to improve women's health outcomes. Basically, it's a survey-based research paper to basically identify the recent state of art of our topic of research. There are several critical challenges when it comes to PCOS. Firstly, the lack of awareness among the women regarding the recognition of symptoms, which often leads to delay in seeking help. Delayed diagnosis vary between regions. The Rotterdam criteria is widely accepted, but still leaves room for ambiguity. Heterogeneous symptoms. PCOS presents differently in every woman. Some experience irregular periods, others suffer from acne, obesity, or infertility. Fourthly, psychological impact. Women with PCOS are at a higher risk of anxiety, depression, and body image issues. Fifthly, limited treatment options. Most treatments are symptomatic. For instance, hormonal pills regulate menstruations but don't cure the root causes and other factors also. Also, all of these factors contribute to frustrations and a decline in quality of life for women dealing with these conditions. Advancements in diagnosis. Despite the challenges, we have seen notable progress in the recent years, which we have come across through different research papers. Firstly, AI and imaging. Machine learning is now being used to analyze the ultrasound images, improving the diagnostic accuracies. Secondly, biomarker research. New research is exploring genetic and metabolic biomarkers for earlier and more precise detections. Thirdly, lifestyle monitoring. Smart wearables and health apps are now help tracking the menstruation cycles, weight, and mood patterns, offering real-time data for better decision making. Uh, Advancements in treatment and management. When it comes to treatment, the focus have shifted from one size fit all to more personalized approaches. The some of the advancement in treatments are firstly lifestyle interventions. Diet and exercise continue to be the first line of treatment. Recent study shows that even a 5 to 10% reduction in body weight can dramatically improve the symptoms. Secondly, pharmacological innovations. Beyond metformin and birth control drugs, new drugs have been introduced like insulin resistance and androgen, which can control the insulin resistance and androgen excesses. Thirdly, mental health support. Cognitive behavioral therapy is being integrated into PCOS treatment to address depression and anxiety. Fourthly, integrative medicines. Ayurveda and naturopathy are also being researched as complementary therapies for PCOS management. Some future directions which we have come across to different research papers after reviewing more than 50 to 70 research papers are firstly, education and awareness campaigns. PCOS should be included in school and college health educations to enhance the awareness among the women so that they can understand the symptoms in the early stages. Secondly, holistic healthcare models. Multidisciplinary team including gynecologist, endocrinologist, psychologist, and dietitians should work together for each patient to get a personalized treatment. Third, inclusive research. Current studies lack diversity. Future research must include women from various ethnicities and socio-economic backgrounds in order to get a more clarity about the PCOS and to get more clear approaches for its treatment. Fifthly, policy level changes. Government must recognize PCOS as a public health concern and promote insurance coverage for its treatment. The conclusion for our research work is polycystic ovary syndrome is not just a hormonal imbalance, it's a multidimensional health condition that demands holistic attention as well as personalized treatment. While recent advancement in technology, machines, and awareness give us hope that there is a long way to go. With better research, inclusive care, and supportive policies, we can empower millions of women to live healthier and fuller lives. I would like to thank my mentor, Dr. Akhilesh Verma sir, and my co-authors Neha Gupta, Uditya Prakash, and Shubhanshu Kumar, and the organizing committee at ICTIC for giving me this platform to share my work. Thank you for your time and attention. I am happy to answer your all questions. Thank you.
Thank you, ma'am. Sir, are there any questions?
Yes, ma'am. You have said that AI assisted technique can be used to solve these issues. Can you tell me what sort of data AI system can be fed into to get in
Uh,
better results?
yes, so there are mainly two approaches which I have come across. Firstly, to collect the data related to blood samples, which consist of several hormonal level information, and the secondly, the data set can include the ultrasound images. So you can apply CNN on those ultrasound images to detect whether your ovary has some follicles which can lead to a PCOS. If your ovary is bulkier than normal, and your model is saying that yes, it is bulkier than normal ovary, then you can say that this patient having a PCOS. So this is the one approach. And secondly approach which we are mainly focusing on is to provide the personalized treatment. So it will not restrict only to the ultrasound image or the blood reports. This disease is majorly depending upon how the lifestyle you are living. So the second type of data set on which we can apply machine learning approaches can include your features like related to your lifestyle, your behavior, or the way you are leading your life. Those features can be do you drink alcohol, or what mode of work you are in, and how much anxiety level do you experience, or what kind of support do you get from your family, because this disease is also very much related to your psychological way of living. If you are very much stressed, or your lifestyle is very much stressed, then there is a possibility then that a patient can undergo to matlab it has a very much greater possibility that a female can undergo to a PCOS. So second data set can be related to your lifestyle factors.
Okay, thank
Thank
you.
you. Yes.
So I have one question. So you mentioned that there are still issues with public awareness because many people don't know about the issues and health related concerns. So did you see any papers when you did your review on use of AI with improving the public awareness, or AI and healthcare policy or something similar?
Not much, but yes, I have seen a lot of works which are majorly doing. I have earlier told the that question that we can work upon two kind of data sets. So majorly, most of the research papers are working upon the first kind of data set, like they are using the ultrasound images to predict PCOS. And right now, since I am also a sufferer from this disease, and that's the main motivation of writing this research paper, I have also was not aware for around 2 to 3 years that I am suffering from this disease, and I was continuously ignoring that. And I think there is a lack of awareness, and there should be inculcation of this concept in early school or early education. So that is the, I think, major gap I have seen in the research papers.
Okay, maybe that can also help with your individualized care once you are more aware and you are aware of your symptoms and your health
Yes.
progress. Okay. Thank you.
Thank you.
Hello. Thank you, ma'am. Now we'll proceed to the next presenter.
Thank you so much.
So the next presenter is Miftatul Hudda from University Pendidikan Sultan Idris, Malaysia. Sir, if you're there in the meeting, please give me a response. Or any of the co-authors. If not, then we can proceed to the next presenter. The next presenter is Ramli Mustafa from the same university, University Pendidikan Sultan Idris, Malaysia. Sir, if you're there in the meeting, please give me a response. I think he's also not there. I would again like to call out some people who have missed the presentation previously. Vineet Jogesh Bhole, Meet Wasawa from Charotar University of Science and Technology.
Yes, I'm here.
Okay, sir, you please start with your presentation.
Yes, just a minute. Can you see my screen?
Just a second. Not yet. Have you shared it? No.
Yes. Is it available now?
No. Just a second. No, I cannot see. Can you please share it once again?
Okay. Just a minute. Is it available now?
Yes, sir, it is available. You can start with your presentation.
Okay, sure. So, hello everyone. Good morning. My name is Meet Wasawa. Our paper title is Enhancing Road Safety using LiDAR and machine learning for pothole detection. So basically, this presentation explores an innovative method for detecting potholes using light detection and ranging, which is LiDAR technology, combined with machine learning algorithms. So the study addresses a critical issue of deteriorating road conditions, which significantly contribute to traffic accidents and infrastructure repair costs. So due to some public scarcity of public LiDAR data sets for pothole detection, we use a synthetic data generated to train and validate the machine learning models. And our findings indicate that the LiDAR-based techniques can effectively identify road surfaces, irregularities while maintaining the computational efficiencies. So our main objective is to introduce an innovative method for detecting potholes using LiDAR technology and address the address the unavailability of public data LiDAR data sets dedicated to pothole detection by generating synthetic data. We convert the 3D LiDAR point cloud data set into 2D height maps, extracting the essential features like surface roughness and depth variations. We uses the support vector machine SVM and random forest for binary classification of road surfaces condition. We assess the model performance using matrices such as accuracy, precision, recall, and F1 score. So basically what happened that the LiDAR is also used before, but it is like very time consuming and not scalable also. The vision based method are also done before, but they are also lighting dependent, limited depth info, and etc. So to facilitate the processing of uh, processing, the LiDAR 3D point cloud was converted into 2D height maps where each pixels are correspond to a height axis value for a specific grid cell. The key features extracted were from the height map to aid the classification of road conditions like surface roughness, gradient features, and depth features, etc. So here are the results and discussions. We
I
got the
cannot see the
highest.
slide of results. I can only see the titles.
Just a minute. Can you able to see it now? Are the result slides available?
No.
Okay, I'll reshare it again. Just a minute. Is it available?
Yes.
Okay, so our result found out that the maximum accuracy we've got is 95%, which is using the CNN model, and we've got the highest F1 score using CNN model also, which is 0.95, and we got the highest recall value also using the CNN. So the CNN model demonstrated the superior performance, achieving the highest scores across all the metrics. This suggests that the special features extracted by the CNN are particularly effective for this task. So other methods like XGBoost are also performed well. Random forest and XGBoost also perform well, indicating the importance of capturing the complex data relationship.
Thank you, sir, for the presentation. Are there any questions?
What kind of data you have used, Smith, for the?
So we have generated a synthetic data. We generated it ourselves.
And have you compared the timings also along with
Yes,
accuracy?
yes, we did. I'm sorry, I
Which is
didn't included in it in the results, but we did it.
Which is the most efficient in timing? Or have you done a trade-off analysis between time and performance?
Yes, we did. I didn't have the data right now, but if you want, you can text me. I'll show it to you.
You keep all those things in the presentation. So thank you.
Yes, sure, sure.
So you said you're using a synthetic data for your model, right?
Yes, absolutely.
Then do you have any ideas of how you would be able to validate or adapt the model for some actual road situations?
Yes, so basically the LiDAR uses the 3D.LAS format. So our data set based on this also. So we can adapt the data set directly into the LiDAR machines, which helps in realistic conditions also.
Okay, that can still have all the potholes and all those situations.
Yes, yes, absolutely.
Okay. Okay, thank you.
Thank you.
Thank you so much, sir, for your presentation. Now we'll proceed to the next presenter. Divyanshi ma'am, have you joined from another device?
Hello, am I audible now?
Yes, yes, you're clearly audible now. Ma'am, please start with your presentation.
Good afternoon, everyone. My name is Devanshi, and today I'll be presenting my paper titled Development of an Admission Chatbot for a University using LLMs. The structure of my presentation is as follows. The emergence of AI-powered chatbots has significantly transformed the nature of human-computer interactions, particularly in the domain of information retrieval. Large language models such as GPT-4 and BERT play a crucial role in enhancing these interactions by enabling machines to comprehend and generate human-like language. The central aim of this project was to design and develop a chatbot specifically tailored for Banasthali Vidyapeeth with the primary goal of streamlining the admission inquiry process. By leveraging contextual understanding and generation capabilities of LLMs, the chatbot facilitates a seamless user experience, allowing prospective students to access reliable and immediate information related to the university. The system leverages retrieval augmented generation or RAG to fetch factual and contextually relevant information related to the university, such as course offerings, eligibility criteria, and campus facilities from a curated knowledge base. We examined a diverse range of scholarly works and implementations that utilize LLMs for educational and administrative purposes. It is evident that the integration of LLMs into chatbot frameworks is gaining widespread traction. These studies provide a critical insight into hybrid RAG architectures, agentic chatbots, and multilingual interaction capabilities. Drawing inspiration from these works, our chatbot was designed to incorporate state of the art methods such as retrieval, augmented generation, and multi query enhancement for optimal performance. Our system architecture is grounded in the RAG paradigm. It comprises of four primary components: question handling, indexing, retrieval, and response generation. Initially, user questions are processed by an embedding model that converts raw text into numerical vector embeddings. These embeddings are stored in a vector database, which is ChromaDB in our case. The documents within our knowledge base were chunked into smaller passages and indexed using these embeddings. When a user poses a question, the retriever module identifies the most relevant context from the vector store. This context is then supplied to the LLM. We used Llama 3.2 as the LLM, which generates a coherent and contextually accurate response. A predefined prompt template governs the structure of these interactions, ensuring consistency in the model's responses across various queries. During the initial testing, Using a basic retrieval setup, we observed a critical shortcoming. The model failed to retrieve accurate responses even when the correct information was present in the database. As it is visible here, our documents clearly had the information about where do BTech students go for their internships, but the basic retrieval setup was not able to identify that information and retrieve it. So to fix this, we used a multi-query approach, uh, which involves in generating multiple semantic variations of a user's questions to improve the retrieval documents. This method significantly enhanced the chatbot's ability to locate and utilize accurate information, resulting in more precise and reliable answers. To conclude, we successfully developed an intelligent chatbot system that assists with university admission inquiries by combining LLMs with effective retrieval mechanisms. The system improves accessibility, user engagement, and administrative efficiency. We plan to integrate agentic AI frameworks to enable dynamic reasoning and task delegation capabilities. Additionally, we also aim to support multilingual interactions, further broadening the user system's usability. Reinforcement learning and user feedback loops will also be explored to refine models' performance over time. These are the references cited in my presentation and my paper. Thank you.
So, ma'am, how do you measure the performance of your system?
It was measured manually by continuous testing. If
You have an
the
ideal answers for that, and then you can have a semantic similar between your answers and the ideal answers, and you can come up with some number which tells it how
uh,
relevant your answer with the existing answers.
I'm not able to get your question. Can you repeat it?
Are you measuring the performance of your system? The answer what are you getting is correct as per your relevant or not? Is there any way to do that? Do so?
Sir, it was in our prompts we already instructed the language model to give answers strictly retrieved from the document so that it does not hallucinate or provide misinformation, so that all the answers are directly from our documents. So this ensures
How
that
do you measure the relevance of your retrieval? That what I'm asking. How do you measure the relevance of retrieved answer?
so we can sir,
Because RAG will generate the answer, it will not fetch or extract the answer, it will generate answers based on the user's query, right?
no, sir. The model was instructed to generate answers only based on the retrieved text. It was instructed not to generate answers on its own and to respond with "Sorry, I'm not able to answer that question."
Okay, thank you.
Okay.
Thank you, ma'am. Thank you, sir. Now most of the presenters are done who are present today in today's session. We have one presenter from last session, Usha ma'am. You are there in the meeting.
Hello. Am I
Hello.
audible?
Yes, ma'am, you are audible. You can give your presentation right now.
Yeah. Thank you. I'll share my screen.
Yes,
Please let me know whether it's visible or not.
sure.
Is my screen visible?
Yes, ma'am.
So can I proceed?
Sure, sure.
Greetings of the day, all the session chairs and all the participants who are attending this conference. A very good afternoon to everybody. It's a wonderful opportunity for us to give the presentation at this gathering. Before I start, I would like to introduce myself. I'm Dr. Varanasi Usha Bala, working as an associate professor at ICTIS Engineering College. And my team of students who are unable to attend the event today for presentation, and I'm there to present their idea. Just a minute, please. The title of our presentation is Image GPT, which is related with the recognition and the insight into South Indian dance forms using CNN, convolutional neural networks. The main idea behind this work is that till now we have only some gesture recognitions of only dance forms or the images, but we don't have any particular Android app model or any machine learning technique to identify in relation with South Indian dance classical forms along with the mudras. These mudras play a very important role in each South Indian dance forms. For example, we have different South Indian dance forms like Bharatanatyam, Kuchipudi, Odissi, etc., where the mudras play a very important role. Each mudra has its own recognition and importance to identify the intellectual skill, the dance skill of the presenter. So here I'm taking your time to explain the idea. So the main problem statement deals with the creation of the image GPT, which tells about if we give the input of the image, the dance form of the image or the mudra, so it will use the machine learning techniques like CNN and VGG16 forms as the technologies we try to implement. And later on, it can be enhanced for the future scope using with DCNN. So this what we have implemented is like AI powered image recognition system, which takes the mudras as the image input. It may be the image input of directly the images which we have tried to download a data set which is directly available, consisting of 8,000 images, where we secure these image data sets from variable resources like Kaggle and also GitHub. And we included some of our own students who gave the input to these data set. And it also deals with the main advantage of this problem statement is it enables the users, the enthusiasts, and everybody to capture the dance forms, and the user can increase their interest in learning these dance forms. This also helps the traditional dances and their meanings more accurately and easily. The solution we have proposed is this one for deploying the CNN for robust image recognition and accurate identification of South Indian dance forms. Here, we are trying to integrate with NLP, Natural Language Processing System, where exactly it divides the input of the dance form. First, we take the input of the image of the mudra of the dance, and then depending upon the image, it will try to deploy the CNN and VGG16, where exactly it uses 16 layers for cleaning, transformation, organization, and etc. And it identifies and handles if any errors are there. And from there onwards, we try to implement some extracting of the features by application of the filters. So these filters can be overcome by using the max pool two-dimensional technique of CNN. And then with the help of these inputs, which we have obtained till now, so we can identify the dance form, which dance form it is. So this is the system architecture we have proposed. First, we'll give the input image, the captured input image. This is the input image of exactly the Kuchipudi dance form, we say. So we do the image processing of the input for first of all by reducing the noise, and then we implement it using CNN, convolution neural network, and we train the model there for specific dance forms and integrated with the different mudras as the input, which is secured as a resource from the data sets like Kaggle and the GitHub. And from there onwards, we segment the images related to mudras and identify the regions of the dance forms. And then mudra recognition. First, identification of the mudra along with the dance form is done. Then the mudra recognition For example, in Kuchipudi, if we talk, it is like we have around 33 mudras. So each mudra representing to one sign and one action. Then depending upon the mudra recognition, each mudra should have one gesture identification. Then it is associated with the NLP integration. So mudra along with the image, along with the gesture, we try to identify, and the final output is an Android application with the help of image classification with the help of the TensorFlow, and also Android application development with Kotlin plugins. So this is the sample image mudras we have taken as the input. If you just see Anjali mudra, which shows the Namaskara position, Alapadma mudra, which shows the recognition of the hand gesture such that you depict the Mother Earth, the blessing, the namaskaras to the Mother Earth, and the Katakamukha mudra, which serve as the multiple namaskaras to Mother Earth, and Pataka mudra is the signature of showing blessing, as if the dance form is depicted as the main deity, the goddess or the god. So this is the after the mudra is given as the input, we take this gesture. So each mudra is in the mudra, we give the whole image of the person, but we try to concentrate using VGG 16, which has 16 layers to only enhance the encircled positions of this image. And then we apply the gesture recognition using the convolutional 2D layer technique for applying the filters, so that only the mudra can be highlighted together. And this particular gesture is recognized as Shikhara mudra. And then we just say from here, the gesture recognition, we apply some technique called as a dropout layer, where exactly it deactivates the other extra input units with a specific frequency rate. I mean, it can be said that we worked on the factor of 1 by 1 minus rate that covers overall inputs, where exactly only this image of the gesture remains constant. So we take this gesture and then we fix the image, and then we apply the machine learning techniques to identify the gesture. So this solution is different from the other solutions, and we recommend this solution because till now this application is not been hello.
Ma'am, sorry for the interruption, but we are past the presentation time. Can we get to the conclusion?
Yes, please. Yes, please. So this solution is a new and innovative solution we have proposed, and this is the feasibility and execution, where exactly it's an integration of CNN and an NLP, what I have discussed earlier. And the stakeholder the project will be the South Indian dance experts, cultural organizations, enthusiasts and professionals, and the general public who get benefited. And with this, I want to conclude. Thank you.
Is your same model or the architecture is able to work on video instead of images?
Yes, sir, we have tried it, but only a fraction, a frame of a video, we have taken it as an input, and we tried to implement it with a ReLU, sir, rectified linear unit. And again, we have implemented with flattened and dense layers for fully converted layers for removing the noise and all. We tried it, but still we are facing some issues with it. So we have recently implemented the softmax layer also, but we are unable to get the accuracy up to 98%. We are still working on it, sir.
And have you thought on model optimizations as you are going to deploy on the mobile devices?
Yes, sir, because that is the softmax layer what we are trying to implement, where exactly we try to normalize these output scores with into a probability distribution. So we will get the limited values as the output, where exactly we can get the maximum accuracy.
Okay, thank you.
Thank you, sir. Thank you very much for giving me this opportunity.
This is a very interesting project I have seen. So I had a question. So did your data set just contain the Kuchipudi dance form, or did you use some other dance?
We have different dance sets. We have Odissi, we have Bharatanatyam and everything. where exactly we created around 2000 images of our own, where our students only created, and for the created input images, they have pre-processed it and trained it. So the total all 8000 images we got it. We have worked on around 6 dance forms till now, like Kuchipudi, Bharatanatyam, Odissi, and Kathakali, etc. And some 2 dance forms which belong to the rural areas.
Okay. And then, so I'm assuming the mudras will be different for all
Yes,
of them.
sir. Yes, sir. For each, I mean, the rural dance forms will be having limited mudras, where exactly this confined dance forms, Kuchipudi, Kathakali, Odissi, Bharatanatyam, etc., they have minimum 30 to 55 dance mudras, which are defined earlier, sir, predefined.
Okay. And your model was able to classify all of them correctly with
Almost, sir. But if we take the input of the image forms, we are still working on it. We have some small issues regarding the frame rate and all.
Okay. Okay. Again, it is an interesting work.
Yeah,
Great.
thank you, sir. Thank you.
Thank you, ma'am. Thank you, sir. Now all of the presentations are done. We'll proceed to the closing remarks. Ma'am, you can stop sharing your screen now. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on the behalf of whole team, thank you for the support during the 9th version and all the previous 8 versions of the conference. We will be happy to see you in the 10th version in 2026. All the presenters would be getting their digital certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICTIS 2025. Lastly, I also thank both our session chairs, Dr. Dr. Amit Thakur and Professor Vishnu Kumar, for chairing this session. A token of appreciation to the chairs on the behalf of Team ICTIS 2025. Thank you so much for your valuable presence. Now, before ending today's session, I request all the participants, along with the session chairs, to please turn on your cameras so that I can take a quick snapshot of today's conference. We'll just wait for a minute, let everyone turn on their cameras, then I can take the snapshot. Okay, I think I'll take the snapshot now. Okay, it's done. Thank you, everybody. This was a great session. We can end this meeting now.
Hello, ma'am.
Hello.
Hello, ma'am. I am Shukrasha Himu. Ma'am, please, can you open the slide where my information was open because I want to take a screenshot?
Yes, sure, sir. I'll display a flyer. You can take the SS.
Sure, sure. Thank you.
Just let me know when you've taken the screenshot, okay?
Sure, ma'am.
Yes. There it is. You can take the SS.
Yes, ma'am. I have completed. Thank you.
Okay, okay.
Hello. Can you give me that chance too, so that I'll click a picture?
Sure, ma'am, but actually, you were scheduled in the last session. So that flyer is not included in this PPT.
Okay. Is there any possibility that at least my shared screen is visible here so that I can click a picture?
Okay, let me just share that PPT, then you can have the SS.
Yeah. Okay. Shall I share that PPT?
Okay, you are going to share your PPT, right?
Yes. Yes.
Yes, sure, sure. You can take the screenshot.
Yeah, it's done. Thank you.
Thank you. Now we'll end the meeting.
Yeah. Hope you are doing good after the mishap.
Yes. Okay, there's just one more flyer. Mohammed sir, I've shared your flyer. You can even take the screenshot if you want. Just let me know when you're done so that we can end this meeting. Is it done?
Done, ma'am. Thank you.
Okay.